a thing, but I like to categorize them because if you recognize what type, it's kind of neat to have it on your study sheet, then you just go about it the same way every time. But so type 1, it's what I call the profit or revenue types of questions. And what's different about these other types, you need to create a table with the info given, right? You're going to have to make your own table. Quite often I provide it, but if not, then you know that it's supposed to, like, these are general steps. Some of the key words that you want to look for when it's this type is you're making some kind of profit or revenue, or you're selling items, tickets, you name it, right? So you're like, okay, I'm kind of like in the money making type, okay? Maybe I should call it the money maker or something. I don't know. So steps: make a table with 3 entries like this. So whatever cost or price is being charged for each item, that's generally what I start with, and then number of items or tickets or what have you, like bookings, and then at the end you'll have a profit column, which is basically these two numbers multiplied, right? So if you're selling a ticket for $10 each and you sell 500 of them, the profit will be 10 times 500, right, to get your 5,000. So that's how it goes. These two don't matter where you put them. Like if you, by any reason, you flip this, it doesn't really matter. What does matter is, this is where you have to be careful. There are 3 columns. This last one is always L2, okay? Or your Y variable, this last one. Okay, so this is important that you know that this is always, that last one is going to go into L2 no matter what. L1, you will have to decide which one of these goes into L1. It's based on the question, right? The question will be like, hey, find the equation that compares the cost and the profit, or find the equation that relates the item sold to the profit. So either one of those, but make sure you don't go L1 and L2, right? That's a common mistake. L2 is always here. Whether this or this is L1, that is the question. So let's keep going. More steps here. Enter cost or items into L1, profit into L2, right? There it is. Profit goes into L2. Note, what goes into L1 depends on the wording of the question. Does it ask for, relating the cost and the profit? If so, then you would put the cost into L1 and the profit into L2. If it says, hey, find the equation that relates the items sold and the profit, then you put items into L1 and profit into L2. Okay. So you're just going to have to watch out for that. And then third, perform the regression using quadratic regression. Make sure that your resulting equation does not have a equals 0, okay? That's very important, because that would make it a linear equation, which is not what you want. And you know what the main reason is for you to getting a 0 for A is that you put the first two like this is L1, this is L2. That's usually why that happens, okay? Since L1 and L2 are being used, turn on plot 1, okay? I would suggest that. And then use Zoom 9 to help you see the graph. But you have to adjust the window until you see the entire parabola. Okay? You want to adjust your window accordingly, because Zoom stat doesn't necessarily solve your problems. Okay, so a couple more things here. generally the focus is going to be, generally the questions of this type will ask you how profit can be maximized. I would probably underline, right? How can you maximize the profit? So it'll ask you what price should you charge to get the maximum profit. Okay, that means that you'll find the vertex. You'll have to find the vertex. A break-even situation happens at the x-intercepts. Okay, break-even. That's just probably worth underlining. You don't make any money at the x-intercepts. Okay, so why do I have those two graphs there? If you relate cost versus profit, right, that'd be this scenario, or you could do items sold versus profit. So this you make two scenarios. Regardless of which scenario you're working with, profit always goes on the y-axis. Okay. That doesn't change. So profit here, profit there, in dollars. What changes under the first circumstance, right? You're gonna go cost, like whatever the cost is per item. And on the second curve here, we're gonna have items sold. Along the x-axis. So here you have L1 for cost, L2 profit. Here you have items into L1, profit into L2. So under this circumstance, the vertex here, you're going to get a certain price you should be charging, and the y value will actually be the maximum profit you can possibly make. Hope I'm not going too fast. Whereas in this scenario, just look at what's down here, right? You'd go items, morning, max profit. So under both of these, either one would essentially give you the highest profit you can make. Okay? The only difference is here the X value would say like, hey, if you charged, $13 per person, you would maximize the profit. Versus over here, it would say, hey, if you sold, 320 tickets, you would maximize the profits, right? So they both give you the same maximum profit, but the X value will be different. So that's how it does matter what you type into L1 and L2 because you're given slightly different info. Maybe I'll just say, I'll mention that over here at the x-intercept and over here at this x-intercept, that's break even. Because you wouldn't be making any profit there, right? It'd be zero profit at that point. And you might ask, well, what about 0, 0 over here? Isn't that break even? Well, if it's 0, 0, you haven't even done anything, right? You haven't sold anything. So that one we wouldn't really consider as a viable answer here. And here's where I just want to briefly describe or talk about the dynamic. So I think you would all, some of you are in business maybe. There might be somebody in here taking business, but there's a phenomenon that if you, the companies always try to find a sweet spot for their pricing, right? So if you increase the price of something, you'll make more, right? Let's say an iPhone. So they get that price where they would sell the most and they would make the most money. But if they keep jacking up the price, you would actually start selling fewer of them and so your profit would actually start going down, right? So finding this highest profit, it's kind of like the sweet spot, like it's the best price to charge to make the most money. Okay, so that's the dynamic here. That's why you have a parabola in this scenario. Because, and I think of hotels as well. If you book hotels, some of them might be on the cheaper end, right? They sell more, right? Some of them might be on the higher end, on the more expensive. They sell fewer room, or they book fewer rooms, but they still make about the same amount of money as a cheaper hotel that just has maybe all rooms booked every time, right? So that's also something, a dynamic that's happening here at the same time. Okay, so let's do an example on page 54. I'm just gonna say you gotta read these very carefully. You might think they're always the same. They're not. Okay. So if you're creating a table, and let's read this first. A movie theater charges $1.80 per ticket. That's the good old days, right? The cheapies, cheap theaters. At this price, it sells approximately 400 tickets per day. The manager has observed that for every 10-cent increase, 40 fewer tickets are sold. This is important. This is going to tell us how to make our points, right? Tells us how to create more points. Okay, that's very important, that little piece of information. So you should have been like, okay, there's money, 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 right? And so this is a profit type, right? Type 1. So you would go to your study sheet and you would probably say, well, I know that I'm supposed to put the cost per ticket, per ticks, that's what I'm going to say there. I'm going to put that first. And this would be number of items. So in this case, it's number of tickets sold, right, that are being sold. And the last one will be your profit, which is cost times number of tickets. That's how you come up with that column right there. So let's create this first. Let's create and fill in this table. 0 points given, okay? But the question does tell us, let's go up here. If it's $1.80 per ticket, okay, that goes in here. It tells us that we're selling 400 tickets per day. So it gives you a starting point. So in the profit column here, you just go $1.80 times 400, and just multiply that. You know what? I'll show you. We'll do the multiplication later. I'll show you a trick there. So for now, we'll just leave it like that. Now we're told, now you got to come up with your new points. If a 10 cents increase in price will give you 40 fewer tickets. So what it's saying is if you were to add 10 cents to this, which would get you to $1.90. So if the movie theater goes to $1.90, what happens to the number of tickets you're sold, that you're selling? 40 fewer of them are sold. So you actually drop this by 40. So you will be selling, your ticket price goes up, but your number of tickets sold goes down. Okay, that's basically what's happening here. And so this would be then, the profit under this circumstance would be found by just going $1.90 per ticket times 360 tickets. So just leave it like that. One more time. If you add 10 cents again, right, you add 10 cents again, that gets you to $2 per ticket. Hey, guess what? You increased it by 10 cents, you'll sell 40 fewer tickets if you do that. So 360 minus 40 gets you to 320. And so naturally, it would be $2 times 320. And we'll come up with this in a bit. Okay. So you've created your table. Perfect. Now you have points. I'm going to say something about quadratics. You need to have at least 3 points for quadratics. That's why I do 3 rows. Okay, you need at least 3 rows. If you have more than 3, no big deal. You can keep going. But 3 minimum, right? 3 points minimum. Okay, that's a thing about quadratics. For linear, like a line, a straight line, 2 is all you need. For a cubic, you need more, but for a quadratic, you need 3. So determine the equation relating the ticket price and the profit. So I will always be very specific there. Ticket price and profit. So ticket price will go into my L1, and the profit that I make, and it's always going to go into L2. Profit always goes into L2. Revenue is the same thing. Okay, if this had said revenue, we actually mean profit. Let's go / revenue, just in case we come across that. Okay, so let's go ahead and do that. All I need you to do is stat calc quadratic regression. Okay, that would be the keys. You know what, to be honest, anything you give me there I'll accept, but I don't want you to have to write out that long second L1 second. Like, don't worry about that. I don't need that part. And so we'll come up with our equation here. What I like you to do normally is you go to the table, and ticket price is over here, right? The cost. So just tell me I put this into L1 and I put this into L2. Just go ahead and do that in your work when you do the test. So let's go to our, how do we do this again? If you did your homework, you'll know. Stat, edit. I'm going to clear everything that's in there. I hit clear, enter. And we're going to go 180, 190, 2. I'll tell you this, your calculator will sometimes show that it rounded the number you entered, but it's actually not going to round it when it calculates it, okay? Now, watch this. Don't enter this into L2. You want to go to profit, and I'm going to type it in exactly the way it is here, guys. Watch. 180 times 400. Enter. That's 720. That's when I write it down. And then it's 1.9 times 360. That's 684. It's just because sometimes the numbers are uglier, and so this makes it a little faster. And you're not double calculating. Okay, so we've got 3 points. I will make a note here. Hold on. Plot 1 is on. Okay. And then I'm going to go zoom stat. Okay. Just to remind you that I'm doing that here. So I'm going to go y equals, plot 1 is on, good. I'm going to clear everything that's there. It doesn't matter, but let's clear for now. And so we're going to go, let's do the buttons again, even though I probably have it somewhere. Stat, calculate, quadratic regression, second 1, comma, second 2, comma, alpha, trace, select Y1, because we wanted to paste it into Y1. If you don't do this, it's not going to paste it into Y1. And then let's run it. And there it is. So I'm going to write that down. Negative 400x squared plus 1120x. And guess what? C is 0. My y-intercept is 0, which is what I expect. If I don't sell any tickets, I'll make 0 profit. Okay. So let's graph this now. You can try zoom stat. I'm going to do that. Okay, zoom 9 is basically zoom stat, zoom 9. And it's not the greatest, but at least I see my curve. You should know, okay, this is pointing down, so it's doing this, okay? So let's go to window. My X-min, I will immediately go -5. My Y-min, I will also go -5. I'll put both of the mins into a negative state. I'm going to graph it again to orient myself, see what happened. It's a little overkill. But what I still need to do is I need to increase my X max and my Y max, right? So I'm going to go window, X max, how about we go +5 there? And my Y max, I'm going to go 1,000. Let's see if that does the trick. It's pretty good. So just to give you an idea, it was zooming into these 3 points that you've created earlier, right? And so you've adjusted your window to see all of, like you want all of that quadrant there. And you might think, do I really need -5 for X-min? No, probably not. You could probably go -1 if you wanted to for X-min. And then you're focusing more onto quadrant 1, okay? So keep that in mind. So now that it's visible, let's answer the rest of the questions here. Basically, after this, it's the same as before. Now you're just going to go find points. What ticket price would result in the maximum profit? What is the maximum profit? Right, we're focusing on maximum profit here. So let's find the vertex. Find the vertex here. We're going to go second, trace, max. So let's go ahead and find that. Second, trace. You have to use max. You cannot use min. And remember, your vertex is somewhere here where my pencil is. So you got to go all the way to the left of it. Enter. Go to the right of it. Enter. So now it's going to find the vertex for you. So it's 1.40, 784. I'm just going to say this because it happens every once in a while. I don't want you to, some students just, if they graph it, they'll just use their cursor to kind of get close to it, and then they'll just write down that number. I want the exact, right? The exact number, so don't be tempted to do that. So, ticket price. This is your ticket price. A ticket price of $1.40 will maximize profit. So that would be the first part of this question. Okay. And then the second part is the max profit is $784. Okay. So you've answered both questions with the vertex, basically. Okay, now I want you to think carefully here. How many tickets are expected to be sold at the price in C? Right, with this price. And this is where I want you to remember profit is equal to price times number of tickets. That's what profit always amounts to. So we've just calculated a ticket price and the profit up here. So we're going to enter the 784 here. The price is $1.40 and number of tickets to be determined. What would you do there? Well, you basically just divide both sides by $1.40. So number of tickets is 784. 784 divided by 140, 560 tickets. So you're expecting to sell 560 tickets at this price. This is expected, right? If this had been a decimal, you would have had to round to a whole number, okay? Sometimes when you do this, you get a decimal. Because it's number of tickets, it's discrete data, right? So we need to round if necessary. Discrete, I'll write that down. Discrete data, round to whole number, okay? And you might ask yourself, why did I do it this way? Why didn't I use my parabola? Because the parabola doesn't have the number of tickets on it, guys, right? It only has price per ticket and the profit. So we had to use this formula. One more. What ticket price or what ticket prices would give / yield, they mean the same thing, would give or yield a profit of $450. Explain why there are two possible prices. Okay, so we're gonna let y2 equal to 450, and you're like, why is that? Well, because remember, profit is your y variable. So let's go ahead and do that. Y equals, we're gonna go 450, hit graph. So this is your profit of 450. So there's an instance where it happens here and another one where it happens here on its way down. So let's find both of them, both intersections. So I'm going to go second trace intersect. And I always like to make a little sketch for this. I go like this. We know it starts at the origin here. It goes like that. And this is our 450 line. So let's find that first instance and the second instance. This is basically the price per ticket at each intersection. Second trace 5. I'm going to find the first one. You're not subtracting here, okay? It's just 49. This is 49 if you round it. This is 2.31. So you could either charge almost like about 50 cents per ticket, or you could charge 231. Both of them would give you the same result, the same profit. And I'll say this. Ticket prices of 49 cents or $2.31 will result in a profit of $450. Ticket prices of. And here's the reasoning. A lower ticket price will have more sales. A higher ticket price. Fewer sales. I'm going to box this in later. Regardless, you get the same profit. Okay, so this is kind of an explanation as to why that is. I'm gonna wait with the graphing for now. I want you to try 56. I want you to go to page 56. I will do the graph yet. Not too concerned with it right now. But we're gonna go to 55. And I want you to fill in the table, come up with the equation, answer basically all of those questions on that page. If you need to consult with your neighbor, you can do that. If you prefer to work on the whiteboards, you can do that too. But I'll give you some time to do that. Okay, so make sure you always know that your tables, this always has profit at the end. Okay, and then the other two you have to figure out. One is going to be some kind of cost or price per, and the other one's going to be amount sold. And I actually purposely flip it on you, like on page 57. The monthly fee has been the first thing that I normally put down, like the cost, and then the number of items goes second, but I flipped it on you, but it doesn't matter, right? What matters is that you have profit on the last column here, and that goes into L2, okay? So I'm gonna say 57. I'm going to say 57 for sure. That's this one. And then I also want you to try page 60. And you might, 60 is going back to the good old days, okay? 60 is like, I just give you an equation. You're not doing a regression, guys. It's not always regression. If you're given an equation, you type that into your Y1. I should say this under here. I will say turn off plot 1. Okay, this is on page 60. Because it's not a regression, not a regression. You are given the equation, so therefore plot 1 is, and I'm telling you that because your calculator will sometimes complain when you try to graph. It'll say it can't do it, right? So you turn off plot 1, it will solve the problem for you. So 57 and 60, if you have time after me finishing off this on page 55, you can still try another one, get started. At least do the table and the equation. If you don't want to do all of it today, that's fine. Let's go to 55 here real quick. This is back to the movie theater. Graph the relation between the ticket price and the profit. No problem. Oh, I should have, yeah, this is where it's going to bite me because you don't have this equation on your calculator anymore, okay? So what I will do here is I will just give you just copy it, okay? So basically, for this graph, I know my vertex. My vertex is 1.40, 784. This is on page 55, in case you're still wondering, okay? My x-intercepts would be 0, 0, as well as this one out here somewhere. I already calculated that. That is going to be 2.80. My y-intercept is also 0, 0. Because remember, most of these profit ones will not will have a 0 as the y-intercept. So I have everything I need to graph this. So watch this. I'm just going to go 1, 2, 3. I'm going to go, so I'm actually spacing it out quite a bit. So this is price in dollars. And the y-axis will have profit, also dollars. And I go as high as 784. Watch my vertex, right? So I'm going to go into 800s or thousands. We'll see. 2, 4, 6, 8. Okay, so 200, 400, 600, 800. That'll do. And so 0, 0 is 1 point. I have 280, 0. So this would be 2.5, 275, 280 is right about there. And then I go 1.4. This is 1.5 right here. So 1.4 is right about there. All the way to 784. This is 700. This is 750. This is 780 right about there. So I kind of split it in half, and then so you get your graph there. And don't forget about your equation. I'm going to peek once. Let me just check here real quick. Negative 400 x squared plus 1120x. Don't forget about I am picky with the variables being on there, so make sure you have your x variables for that second number, or else it's a constant, right? And so there you go. That's your graph. Domain and range. What would be the domain and range in this scenario? Domain, we're talking x variables, and it goes from 0 all the way to 280. And you might wonder, why does it stop at the x-intercept? Because you can't have a negative, I mean, you can have negative profit in real life, but for us, it kind of stops there unless clearly indicated otherwise. We're not about real life and math, right? We just stick to dreamland. 0, for range, it's 0 all the way to the highest y value, the highest profit, which is 784. There we go. And that's it. I'm going to stop there. I was going to go a little further with, hey, come up with an equation where you relate the number of tickets and the profit, but I'm not going to do that. Like that's above and beyond right now, beyond the scope. So I'll just say this, homework, 57 and 60, 57 and 60. Okay. This is a regression, type 1. This is equation given. I don't want you to forget those, because those are actually the most common, even in grade 12, right, where you're given the equation. Regressions still are there, but not all the time. Okay, that's it. I'm going to post a key probably to everything. So 57 all the way to 60. If you want to do more regressions, you feel like you need more practice, that's going to be heavy on the quiz. Okay, regressions. So be prepared, prepare for those. Okay.